0, B is 0, C is 1. It is a min term because output is 1. Then I can write as a bar, B bar, C. A bar, B bar, C. It's a product term. Understand or not? I written, okay, this is the form. Listen carefully. Y of A comma B comma C is equal to min terms. All min terms sum together. All min terms are all product terms sum together called as a standard SOP. I written. And I'm going to represent with the notation. This is a M1, this is a M2, this is a M4, and this is a M7. From this, if I consider summation, if I consider, okay, summation is common because sum is there, common, and M. Okay, then I can write as a only suffix. This suffix is called as a decimal equivalence 1247. Summation M of 1247 can represent as a canonical SOP or standard SOP shorthand representation. Standard SOP shorthand representation. Same way here also I can represent with the pi m of 0356. If you observe these two, max terms and min terms, if you observe, here 1 is there, here 1 is not there. Here 2 is there, 2 is not there. 4 is there, 4 is not here. 7 is there, 7 is not here. Here 0 is there, but 0 is not there. Okay, 3 is there here in max term, here it is not there. Based on that, I given that very important note. What is that important note? Same suffix of decimal value is mutually exclusive each other in standard SOP and standard POS for single truth table. What it means? What are the min terms are there? 2, 3, 5. That decimal equivalent value should not repeat in the max term. Please keep in mind. Here 235 will be there. 235 won't come here. 01467 is there. The 01467 cannot come at the standard SOP or cannot come at the min terms form. This is we discussed. And minimized SOP, minimized POS. Here SOP means product term sum together. POS means sum term product together. Their standard SOP means product term should consist of all input variables. Here minimized SOP means at least one product term should not contain all input variables. Here చూడండి A, B is there. Two input variables are there. Here this is a product term. It is missing B. Then it is a minimized. Here it is missing B. Here in the sum term it is missing B. It is minimized POS. Okay. Now they can ask that. Okay, literal. I already said literal in the sense each occurrence of input variable either in the form of complement form or uncomplement form called literal. Okay, A on the input అది కాంప్లిమెంట్ లైన్ అప్లై కావచ్చు, appear అవ్వచ్చు, uncomplement లైన్ appear అవ్వచ్చు. That we can call it as a literal. The total ఎన్ని literals ఉన్నాయమ్మా? 1, 2, 3, 4. A appeared 2 times. Okay, one time is complement form, another time is uncomplement form. B appeared 2 times, but 2 times it has appeared in the form of uncomplement. But I don't want consider 1, but I need to consider 2 times because why I said what I said the definition, each occurrence B occurred 2 times, then I need to consider 2 times. Then here literal count is 4. In this one literal count is 6. Now generally I said that f of A comma B is equal to A bar B plus AB. This is standard SOP. It consists of 4 literals. Now we need to minimize the expression. To minimize the expression, we have 3 methods. What are that one? Boolean algebra, K-map, and the tabular method. I'm using the Boolean algebra because we completed the Boolean algebra. By using that Boolean algebra, in this one, what is the common one? B is common. If you take B is common, A bar plus A is 1. Okay, then f of A comma B is equal to B. Means it is standard expression. It is a minimized expression. Why it is a standard expression? I already said that A, B are there. Two product terms. Each product term consists of all input variable. Here A is missing. Here A is missing. And how many literals are there? Here 4 literals are there in standard SOP. In minimized SOP, how many literals are there? Only 1 literal is there. Okay. Now this is very important. These questions they can ask. Okay, find out min terms of given expression or convert into standard SOP. Okay, convert into standard SOP, convert into standard POS, or find the max terms. Okay, what it means they are going to give the minimized expression. We need to convert into standard expression. For that one, I said that. Okay, I already said we know the minimized expression should missing some literals. Okay, now first we need to find out that. Okay, find the missing literals in each term. Okay, A bar B is there. Here BC is there. The input variables are A, B, C. Here which one is missing? C is missing. Here which one is missing? A is missing. Okay, write the combinations for missing literals. And please keep in mind, we had write the combinations here. They given that A, B, C. Okay, we need to write in this way only. A bar, okay, here they given in the term A bar B, C is missing. C is LSB. A bar B dash. Here B, C, A is missing. Means A is missing is how you need to write dash B, C, dash B, C. Okay, now A bar in the sense 0, B in the sense 1. Okay, 0, 1 I am writing. Here dash dash why I'm keeping, one literal is missing, it can appear in the two ways, 0 1. Here one literal is missing, okay, it can appear in the 0 1. And we have to write the decimal value, decimal equal 0 1 0 is 2, 0 1 1 is 3, 0 1 1 is 3, okay, 1 1 1 is 7. This is the second step. Okay, now third step is repeating min terms or repeating terms. Okay, we need to consider only one time. Repeated suffix consider only one time. Then I can get as a, this is a minimized SOP. Okay, if you want to convert, we will get the, okay, standard SOP only. Standard SOP only. Now we are getting standard SOP 237. 237 summation M of 237. Now when you know the min terms at, okay, standard SOP, we can write, okay, max terms in the standard POS, because why, same suffix should not be repeated here. Okay, the 237 should not repeat here, 0 1 4 5 6. Understand or not? Okay, this is the way we are going to convert. These are problems we discussed. I given homework. Okay, I given homework. Okay, how many members are there? These three problems are I given homework. How many students they completed homework? No one did. Three problems I given for homework. Okay, your wish. I can't force you. When, okay, now the students who have the backlog, they're struggling now. Okay, that is your wish. Okay. Okay, next topic is today. Wait a second. Okay, see here. The today topic is logic gates. Okay, generally logic gate we can call it as basic building blocks for any digital system. Okay, to build any digital system, logic gates are basement block. Without logic gates, we cannot build any digital system. Here I given one example. I hope you won't understand, but in further classes you can understand. Okay, it's a 4-bit adder. To design a 4-bit adder, it is a digital system. First, we need as a one bit. Sorry, four number of 1-bit full adders. We need four number 1, 2, 3, 4. Four number of 1-bit full adders we need. In this 1-bit full adders, again I have to divide into submodules. The submodule here I can get it as a the submodule. I'm going to get okay. We are going to get as a this is some circuit and carry circuit. This sum circuit to design, okay, to design this sum circuit, we need logic gates. Okay, to design carry circuit, we need logic gates. If you observe here also, there is a submodules will be there. These submodules to design, we need logic gates. Logic gates. Here also we have submodules. Here also we have submodules. If you come here, okay, this is the lowest level. Lowest level. In this lowest level, okay, which one we need to design a 4-bit adder? Logic gates. Without logic gates, I can't design submodule of which one sum and carry. If sum and carry circuit is not there, 1-bit full adder, I can't design. Okay, if it is 1-bit full adder not designed, there is no 4-bit adder. Means to design a 4-bit adder, definitely we need the basic building blocks are which one? Logic gates. Okay, now very important thing, types of logic gates. Types of logic gates. Here types of logic gates, there are three types. First of all, there are three types. First one is basic gates. Okay, first one is basic gates. They ask us lot of time 2 marks question. Still your final years we conducted the okay, we conducted the Viva voice. For that, lot of students they didn't tell what are basic gates. Please keep in mind, basic gates are not gate, and gate, or gate. Not gate can do. Okay, not gate can do. Okay, inversion function, and gate can do product function, or gate can do some function. We already know that operators. We studied about the Boolean operators. There are two types of operator: unary operator and binary operator. Unary operator is not operator. Binary operators two types, and operator or operator. These are the basics. Okay, basics. Without these three, okay, without these three functions or operators, okay, okay, we can't discuss digital systems. That's why, okay, they made these operator as a gate. Not operator they made as a not gate. And operator they made as a and gate. Or operator they made as a or gate. The function what we discussed there, here both are same. The logic also both are same. Please keep in mind. Okay, these gates, okay, these three gates, not gate, and gate, or gate. These three are basic gates. Please keep in mind. Basic gates are three types. Okay, they can ask universal gates. This is very important. This is very important. Okay, universal gate, NAND, NOR. NAND, NOR. Two gates are universal gate. First of all, why we can call it as a universal gates? Okay, that we will discuss later. Okay, the name is universal gate. Okay, for that I will ask one question. Who is universal hero in India? Anyone? Who is universal hero? Like Megastar is there in our industry. Okay, Power Star. Okay, like that one person is there, universal hero from Tamil Nadu. Who is that hero?
APJ Abdul Kalam, sir.
Who?
Abdul Kalam, sir.
No. I'm saying hero. See, that all Abdul Kalam is a scientist. I'm actor. Somebody said.
Kamal Haasan, sir.
Yes, Kamal Haasan. Why Kamal Haasan is universal hero? Why they gave the name universal hero? See, the universal hero in the sense he can perform any type of character, any type of role. That's why we can call it as a universal hero. Here also universal gates in the sense NAND and NOR can perform any type of function. That's why it is called as universal gates. Please keep in mind. Based on this, okay, you will get lot of questions. Okay, I will repeat. NAND and NOR are the universal gates. Okay, NAND and NOR are the universal gates. Because why they given the universal gate means these NAND and NOR gates can perform any type of function. That's why they can call it as universal gates. Okay, that we are going to prove also. Now, special gates are exclusive gates. Okay, gates are there. There are two types, XOR and XNOR. Okay, totally. See here, basic gates are 3, universal gates are 2, and XOR gates are, okay, exclusive gates or special gates are totally 3 plus 2 plus 2 is equal to 7 gates. We are going to discuss about 7 gates. Okay, for competitive exam point of view, these are very important for competitive exam. Okay, like PSUs or gate exam, they can ask maximum question from XOR gate only. Okay, now first we'll start with the basic gates, NOT gate. See here, I'm going to start with NOT gate. First thing, for every gate we are going to discuss 5 points. These are very important. These 5 points you have to remember. These 5 points you have to remember. See here. Okay, now first, logic. What is logic, ma? Complement or inversion is the logic for NOT gate. NOT operator also same thing I said. It can, okay, it can take complement. Okay, output is always complement of input I said. Same thing here, NOT gate, complement or inversion. Okay, NOT gate consists of single input and single output. Please keep in mind. This is very, very important. NOT gate consists of single input and single output. There also I said that NOT operator, okay, having only, okay, NOT operator is what I given the name unary operator because it consists of single variable. Truth table, third one is truth table is important. What is mean by truth table? I already said truth table in the sense there is a logic relationship between input and output. Here in this NOT gate, the logic relation is inversion, ma. Now how many input I said, ma? One input. How many output I said, ma? One output. That's why I'm going to consider A, Y. This is input, this is output. Now A is the input, then we can get only two combinations, 0, 1, 0, 1. Now see here, output. Okay, what I said, ma? Complement or inversion. A is 0, Y should be 1. A is 1, Y should be 0. And next one, we need to write, listen carefully, this is important. We need to write standard expression. We need to write expressions or equation. Equation or expression. Okay, technically we can call it as expression. Okay, we can write as a expression, logic expression. Everyone know how to write expressions? Okay, using minterm and maxterm. Minterm means it can generate logic 1 output. Maxterm means it can generate logic 0. Now tell me that minterm is for 0. Okay, summation m of 0. For this here, decimal equivalents are, decimal equivalent is D. Decimal equivalent is, this is 0, 1 only. Okay, here 0. Okay, 0 is the maxterm. Okay, respective of the decimal equivalent is 1. That's why pi m of 1. Summation m of 0. Here only 1 is there. See here, only one combination we are having, m of 0. And okay, summation m of 0. A is equal to 0. I can write as a bar or not. A is equal to 0. I can write as a y is equal to a bar. Y is equal to a bar. Okay. Then symbol is a symbol. Symbol I'm going to talk. Okay, here I can write as a, this is a standard expression. Then I can write as a y is equal to a bar. This is the expression. Output is always complement of input. That's why bar. Or I can write as a y is equal to a prime. Y is equal to a prime. Now, symbol is, I'm going to write, here it is a bubble. This is the input A. Y is equal to a bar. Y is equal to a bar. Please keep in mind. This bubble can invert. Bubble having the complement. Bubble having the complement. Sometimes you can get in this way. This we can call it as a buffer. This buffer. Okay.
అంటే ఇప్పుడు ఏ రివర్సేను యాదో రోజు చేస్తాను
యాదకి ఇంత పని చేసినప్పుడు
నాకేం పని పడుతుందా నువ్వు సోమవారం పంపించేది
Okay. Who is that? Kranti, right? A section. 451. Right? A section student, anyone student. Ishwaraditya,
Yes, sir.
Kranti 451, right?
Yes, sir.
Yes, okay. Note down his name. We'll discuss later. Yeah. See, there is no bubble that we can call it as a buffer. Okay, with the bubble, it's a not gate. Generally, buffer, I can tell, listen carefully, buffer, what it can do means y is equal to a. What it means, y is equal to what it means, ma? Then apply. It is 0. Who is making this one disturbance? Ishwaraditya, you mute yourself. See here, buffer in the sense, what is the input? Okay, safety will come at the output. That we can call it as a buffer. Okay, the input what we can apply, we can get complement. That is a NOT gate. Please keep in mind. This is NOT gate. The next we'll move to the OR gate. Okay, please keep in mind. This is a logic. First point is logic. This is logic. First point is logic. Please, you have to remember. Everyone has to remember logic. When one of the input variable is logic 1, then output is logic 1. Okay, when one of the input variable is logic 1, then output is logic 1. Please keep in mind. Okay, how many minimum number of input variables and output variables? Okay, minimum 2 input variables. Minimum 2 input variable. Minimum 2 in the sense, maximum how many? Okay, minimum 2, then maximum is 3, 4, 5, 6, and so on. Okay, there are minimum 2. I said that minimum 2 input variables. And okay, how many outputs? Single output. Now I written 2 input variable truth table and 3 input variable truth table. Please keep in mind, when it is a 2 input variable truth table, okay, now we know that how many combinations we can get? 4 combination. That combinations from 0, 1, 2, 3. 0, 1, 2, 3. Okay, in this 0, 1, 2, 3, 4 combinations, okay, I can get 4 binary combination. 0 is 0, 0, 0, 1, 1, 0, 1, 1. Now I said that, please keep in mind, logic is when one of the input variable is logic 1. In A and B, any one input is 1, output is 1. Now see here. Okay, first combination, leave it, we'll come back. 0 and 1, B is 1 here. B is 1. That's how output is 1. In this combination, A is 1, output is 1. Okay, in this combination, both are 1. But I said that at least one should be 1. Okay, A is 1, B is 1, then output is 1. First combination, 0, 0. See here, 0, 0. First combination, 0, 0. For 0, 0, okay, both inputs are 0. But here, what I said, any one of the input variable is 1. Here, okay, no, okay, A is not 1, B is not 1. That's why output is 0. Please keep in mind. Okay, here minterms. What are the minterms? 1, which one can generate? That are minterms. Minterm. And 0 generate. This is a max term. Then I can write as a y of. Y means which one? Output. Y of A comma B. Input variables of summation m of 1, 2, 3. What it means? Summation means minterms has to come. Okay, this is minterm. This is minterm. These 3 are the minterm. Respective of this decimal equivalent is 1, 2, 3. 1, 2, 3. Okay, that is equal to pi m of 0, because it is a max term. Pi m of 0. You understand or not? Now the logic expression. Listen carefully here. The logic expression, how I'm going to write? Okay, in the 2 ways I can write now. Okay, here 1, 2, 3 are there. Please keep in mind 1, 2, 3 are there. 3 minterms are there. The three minterms you can. Okay, I will write it here. See here, I will take new slide. Okay, summation m of what you got, ma? Okay, see here. Summation m of 1 comma 2 comma 3 you got. That is equal y is equal to a comma b. Summation of 1 2 3 it means I can write as this is shorthand represent m1 plus m2 plus m3. Is it correct or not? Summation if you send inside m1, okay, summation plus m1 plus summation of m2 summation of m3. M1 how I can write for two variables a bar b, a b bar m2, m3 is ab. Okay, in this one, this is standard expression, this is standard SOP, this is shorthand representation, this is standard SOP expand expression, expand, I'm writing expansion. Here it is a simple way, that's a shorthand representation. Or I can write as a canonical form, I already said canonical form. Okay, now we need to minimize this. Okay, how we are going to minimize? See here. Okay, from this which one is common? A is common. If you take A is common, what I'm going to get? B bar plus B. B bar plus B is 1. Then I can get A bar B plus A. Because this B bar B plus 1. Then I get it as a bar B plus A. Now literal redundant law. A bar B plus A. Okay, A bar is going to get cancelled. Then I can get it as a plus B. Mean, okay, this one standard SOP, if you minimize this, we got as a plus B. Please keep in mind. Okay, a plus B we got. See, this summation m of 1 2 3, summation m of 1 2 3. Okay, if I convert to standard SOP, if we apply Boolean algebra, I got as a plus B. Okay, this much, okay, length, I don't want to take more. Simple I can write. Listen, here summation m of 0 is there. Based on that I'm writing, because here 3 minterms are there. I don't want to waste the time. Here summation m of 0, please keep in mind. Summation m of 0 means, okay, here in this combination, 0 combination, we have in this combination 0 0, a is 0, b is 0, I got max term. Based on that I can write directly, please keep in mind. How I can write, ma? When we are going to write the max term, a is 0, b is 0 means what it means? A is 0, b is 0. We can write complement form or uncomplement form. Please tell me. You have to tell the answer. We have to write a is 0, b is 0. When we are writing max term, when it is a 0, we have to write complement form or uncomplement form. Please tell me. Uncomplement form means a I have to write, b 0 means b. And max term is the sum term or sum term or product term? Max term is a sum term or product term? Max term. Today again I revised. Max term is a sum term or product term?
Product, sir.
Sum term. Please keep in mind. చదవట్లేదమ్మా, అదే తెలుస్తుంది. ఏం చెప్పాను? చదవండి బాగా. ఈచ్ ఏం రాశాను? ఈచ్ సమ్ టర్మ్ ఈజ్ అ మ్యాక్స్ టర్మ్. నేను రివర్స్ అడుగుతున్నాను. మ్యాక్స్ టర్మ్ ఇస్ ఎ సమ్ టర్మ్ ఆర్ ప్రొడక్ట్ టర్మ్? చెప్పండి. అండ్ మ్యాక్స్ టర్మ్ క్యాన్ జనరేట్ లాజిక్ 0 అవుట్పుట్. ఇప్పుడు నేను లాజిక్ 0 తీసుకున్నానా, లాజిక్ 1 తీసుకుంటున్నాను ఇక్కడ? వాట్ ఈస్ వాట్ ఐ టేకెన్ హియర్? y is equal to 0 తీసుకున్నానా, 1 తీసుకున్నానా? y అంటే అవుట్పుట్ కదా. నా వాయిస్ వినపడుతుందా లేదా? హలో,
వినిపిస్తుంది సార్.
see here, y is equal to 0 అంటే నేను మ్యాక్స్ టర్మ్ రాస్తున్నాను అని చెప్తున్నాను. మ్యాక్స్ టర్మ్ ఇస్ ఎ సమ్ టర్మ్, మిన్ టర్మ్ ఇస్ ఆల్వేస్ ప్రోడక్ట్ టర్మ్. ఓకే, ఇక్కడ a is equal to 0, b is equal to 0 వచ్చిందంటే అన్కాంప్లిమెంట్ ఫామ్ రాస్తున్నాను. ఓకే, దెన్ ఓకే ఇట్స్ సమ్ టర్మ్ రైట్, a ప్లస్ b. అంటే ఇక్కడ మిన్ టర్మ్స్ 3 ఉన్నాయి. ఈ 3 బేస్ చేసుకొని మినిమైజ్ చేయాలి అంటే ఐ హ్యావ్ టు డూ దీస్ ఆల్ స్టెప్స్. నేను షార్ట్ కట్ లో రాస్తున్నాను. దేనిలో రాస్తున్నాను? ఇక్కడ మిన్ టర్మ్స్ 3 ఉన్నాయి, మ్యాక్స్ టర్మ్ ఒకటే ఉంది. ఆ ఒకటి బేస్ చేసుకుని రాసేస్తున్నా ఎక్స్ప్రెషన్ y is equal to a plus b అని రాసేస్తున్నా. ఓకే, దిస్ ఇస్ ద వే we have to write the expression. Okay, next 3 input variables ma, a b c. 3 input variables a b c. If I consider for OR gate, this is decimal equivalent. Here I am going to write 0 1 2 3 4 5 6 7, total 8 combinations I can get from 0 to 7. Now what is the logic ma? When one of the input variable is logic 1, then output is logic 1. When one of the input variable is logic 1, then output is logic 1. ఇక్కడ అవుట్ ఆఫ్ 3 లో బాగా అబ్జర్వ్ చేయడమా, ఫస్ట్ కాంబినేషన్ లో అన్ని 0 ఉన్నాయి. అన్ని 0 ఉన్నాయంటే అవుట్పుట్ 0. మరి రిమైనింగ్ కాంబినేషన్ చూడండి, మినిమం ఓకే అట్లీస్ట్ ఆర్ వన్ ఆఫ్ ద ఇన్పుట్ వేరియబుల్ ఇస్ 1. ఇక్కడ 0 0 1, c is 1, here b is 1, here bc are 1, here a is 1, here ac are 1, okay ab are 1, 3 are 1. That's why we got as output are 1. Okay, then here again, okay you can tell me that here again you can tell me for this y of a comma b comma c is equal to summation m of min terms. అంటే ఏమని చెప్పాను మా, 1 జనరేట్ చేసేవన్నీ min terms, రెడ్ కలర్ టిక్ కొట్టినవన్నీ min terms. దీస్ ఆల్ ఆర్ min terms. ఏమొచ్చాయి డెసిమల్ ఈక్వలెంట్ 1 2 3 4 5 6 7. Okay, these all are min terms. Next pi m of product. Okay, max term I'm writing. Okay, here only one thing we got as a 0. ఇప్పుడు నేనేం చెప్తున్నా అంటే 1 2 3 4 5 6 7 ఈ 7 తీసుకొని మినిమైజ్ చేస్తే విల్ గెట్ వన్ ఈక్వేషన్. బట్ అదంతా నాకు లెంతీ ప్రొసీజర్. ఇక్కడ ఒకటే ఒక మ్యాక్స్ టర్మ్ వచ్చింది. ఆ మ్యాక్స్ టర్మ్ బేస్ చేసుకొని డైరెక్ట్ ఐఎమ్ రైటింగ్ ఎక్స్ప్రెషన్ y of a comma b comma c is equal to, I'm writing for this a is 0, b is 0, c is 0. Then I can write as a b c. Okay, and it is a max term, right? Max term is a sum term. Then I can write as a plus b plus c. Y of a comma b comma c is equal to a plus b plus c. I can write directly. And symbol, please keep in mind. The symbol is ab. 2 inputs are there, and I'm going to draw OR gate is in this fashion. This OR gate symbol. This is a AB are there. Then I can write as a plus b. This is a y is equal to. If third input we given, okay, then I can write as a y is equal to a plus b plus c. This is a symbol. And very important thing, listen carefully, ma. Okay, enable input and disable input. 2 marks question adugutaru idi. What is the enable input and disable inputs? సింపుల్ గా ఒక ఇన్పుట్ ని నేను ఫిక్స్ చేస్తున్నా. ఐఎమ్ గోయింగ్ టు ఫిక్స్ వన్ ఇన్పుట్ యాజ్ ఏ. అనదర్ ఇన్పుట్ ఓకే ఐ కెన్ అప్లై either 1 or 0. ఫస్ట్ 1 అప్లై చేశాను. అప్పుడు ఏమొస్తుంది మనకి అవుట్పుట్ చెప్పండి? అవుట్పుట్ ఏమొస్తుంది? ఓకే, ఇక్కడ ఏమని చెప్పాను? ఏబి ఆర్ దేర్, y is equal to a plus b. b ప్లేస్ లో 1 or 0 అప్లై చేస్తున్నా. దెన్ y is equal to what we can get ma, a plus 1 వస్తుంది. ఫస్ట్ 1 అప్లై చేస్తే a plus 1. Okay, we know that 1 plus anything is 1. 1 plus anything is 1. Okay, output, if input is a, another input is 1, a plus 1 is there, then we can get as a 1. Next one is, okay, if input is 0, okay, then I can write a y is equal to a plus 0. a plus 0 is a. ఇప్పుడు బాగా అబ్జర్వ్ చేయండి, 1 అప్లై చేస్తే I got output is 1. Okay, another input 0 అప్లై చేస్తే I got as a. ఇప్పుడు నీట్ గా చెప్తాను, లిసన్ కేర్ఫుల్. 1 input variable I fixed as a, another input ని 1 or 0 అప్లై చేస్తాను. అవుట్పుట్ ఏమొచ్చింది? Based on this, okay, another input is 1, then I got as output is 1. This is a 0, another input is 0, then output is a. Then I can tell here, listen carefully, 1 అనేది 1 అప్లై చేసినప్పుడు OR గేట్ కి 1 అప్లై చేసినప్పుడు ఫిక్స్డ్ ఇన్పుట్ ఉంది. దట్ ఫిక్స్డ్ ఇన్పుట్ ఈస్ డిసేబుల్ అట్ ద అవుట్పుట్ సైడ్. డిసేబుల్ అయింది అంటే ఏ రాలేదు, నాకు 1 వచ్చింది. ఓకే, నెక్స్ట్ హియర్ అనదర్ ఇన్పుట్ 0 అప్లై చేసినప్పుడు దిస్ ఫిక్స్డ్ ఇన్పుట్ ఎనేబుల్ అట్ ద అవుట్పుట్ సైడ్. Okay, again I will repeat, listen carefully. When I'm going to for OR gate, when I apply 1, okay, it disable the fixed input at output side. It disable ఈ 1 వల్ల ఈ ఏ ఫిక్స్డ్ ఇన్పుట్ అనేది డిసేబుల్ అయింది అవుట్పుట్ సైడ్. అదే 0 అప్లై చేస్తే ఓకే ఏమైంది, 0 అప్లై చేస్తే ఇన్పుట్ గా ఈ ఫిక్స్డ్ ఇన్పుట్ అనేది అవుట్పుట్ సైడ్ ఎనేబుల్ అయింది. దట్స్ వై ఇట్ ఇస్ కాల్డ్ యాజ్ ఫర్ OR gate disable input is 1. అంటే 1 అప్లై చేసినప్పుడు వాట్ ఎవర్ యూ కెన్ అప్లై అదర్ ఇన్పుట్ ఇట్ ఈస్ గోయింగ్ టు బి డిసేబుల్. అండ్ డిసేబుల్ ఎలా వస్తుందమ్మా, 1 గా వస్తుంది. ఓకే, నెక్స్ట్ ఎనేబుల్ ఇన్పుట్ ఇస్ 0 అప్లై చేసేటప్పుడు ఫర్ OR gate ఎనేబుల్ ఇన్పుట్ ఇస్ 0 అప్లై చేసినప్పుడు ఓకే వాట్ ఎవర్ యూ కెన్ అప్లై ద ఇన్పుట్ దట్ విల్ బి ఎనేబుల్ అట్ ద అవుట్పుట్ సైడ్. దిస్ ఇస్ వెరీ వెరీ ఇంపార్టెంట్. డిసేబుల్ ఇన్పుట్ అండ్ ఎనేబుల్ ఇన్పుట్. OR gate కి ఏంటి మా డిసేబుల్ ఇన్పుట్ 1, ఎనేబుల్ ఇన్పుట్ ఏంటి 0. ప్లీజ్ కీప్ ఇన్ మైండ్. This is about the OR gate. OR gate simple. When one of the input variable is logic 1, then output is logic 1. Minimum 2 input variables and single output. 2 అంటే ఏమని అర్థము, 3 అయినా ఉండొచ్చు, మినిమం 3, 4, 5, 6, 7 answer. 2 input variable కి 3 input variable కి truth table I explain, and disable input and enable input I explain. You have to remember the symbols. These symbols are very very important. Next we'll move to the AND gate. Okay, AND gate. See here, the logic is if all inputs are 1, then output is 1. Please keep in mind, if all inputs are 1, okay, this is a logic, or 1, output is 1. Minimum how many variables, ma? Okay, how many minimum variables? 2 minimum variable. 2 in the sense that should be 2 or 3 or 4 and so on. Now truth table AB. Now we have decimal equivalent. This is 0, 1, 2, 3. Okay, then combinations. 2 inputs are there, 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1. Now y is equal to, I can write as a, okay, output how I'm going to write. If all the inputs are 1, then output is 1. AB 2 inputs are there. When 2 inputs are 1, output is 1. Remaining all combination, output is 0. This is which one, ma? This is a min term. These all are max term. Then I can write as a min term is summation m of 3 only. Pi m of 0, 1, 2, 0, 1, 2. Now, ఏది బేస్ చేసుకుని రాయొచ్చు, మిన్ టర్మ్ బేస్ చేసుకుని రాయొచ్చా, మాక్స్ టర్మ్ బేస్ చేసుకుని రాయొచ్చా ఎక్స్ప్రెషన్? బికాస్ మిన్ టర్మ్ is only one is there, then we can write the expression based on min term. Okay, min term is a product term, right? That's why dot a is 1, b is 1. Okay, complement వస్తుంది, అన్కాంప్లిమెంట్ వస్తుంది. మిన్ టర్మ్ రాసేటప్పుడు a is 1 means uncomplement. A is 1 is a, b is 1 is b, a dot b. This is a symbol. Okay, next 3 input చూడండి ఇక్కడ, 3 input కి I'm going to write as a here, okay, y of a comma b comma c is equal to summation m of only 7. This is a 7 we got output as a 1, means this is min term. Then pi capital M of 0, 1, 2, 3, 4, 5, 6. These all are max terms. This is min term. Only one min term. Only one min term is there, 7. How I am going to write my a comma b comma c is equal to y of, okay, I can write y is, okay, a is 1, then a, b is 1 means b, c is 1 means c, a dot b dot c. And for this one symbol is 3 inputs, y is equal to a dot b dot c. And enable input, disable input. Enable input ఇక్కడ చూడండి, a dot 1 రాస్తే a వచ్చింది, a dot 0 రాస్తే 0 వచ్చింది. మీనింగ్ ఏంటి, okay, one input is okay fixed, other input one apply చేశాను, అప్పుడు మీనింగ్ ఏంటి? a dot 1 a అంటే మీనింగ్ ఏంటి మా? ఓకే, this one is enable the fixed input at output side, అంటే enable input AND gate కి 1 అవుతుంది. This 0 is disable the fixed input at output side, అంటే disable input to 0 అవుతుంది. Please keep in mind. This is about AND gate. Next, universal gates. Okay. See here, why it is called universal gate? I already said. NAND NOR can perform or implement any type of function, okay, or logic. That's why it is called as universal gate. Okay. Now universal gates. First one we are going to discuss NAND. In the name itself, if you observe here, NAND plus AND is nothing but NAND. Okay, or else if I written plus in the sense, you will get confused. I can write in the simple way. Not AND is NAND. Simply I can call it as not AND is NAND. Not AND is NAND. Okay, AND ఏమని చెప్పాను? If all the inputs are 1, output is 1 అని చెప్పాను. ఇక్కడ reverse. If all the inputs are 1, output is 0. Output is 0. Or another way కూడా చెప్పొచ్చా? If any one input is logic 0, output is logic 1. Output is logic 1. ఈ విధంగా కూడా చెప్పొచ్చు. Two ways I can tell. Okay, or okay, AND కి opposite కాబట్టి if all the inputs are 1, output is 0. AND కి ఏం చెప్పాను ఇందాకే? AND కి ఏం చెప్పాను? What I said for AND? For AND, what I said? If all the inputs are 1, then output is 1. NAND it's opposite గా ఉంటుంది. If all the inputs are 1, then output is 0. Output is 0. Okay, here also minimum 2 inputs, 1 output ఉంటుంది. AB. Okay, now just now we discussed AND gate, then opposite now. 1 1 ఉన్నప్పుడు 0, remaining combinations we get 1. ఇప్పుడు నేను రాస్తున్నాను ఇక్కడ. Hello? Okay, I'm going to write. Okay, y of which are the minterms of 1 we got these all are the minterms. Okay, these are max term. Only one max term is there. Then pi m of 3 summation m of 0 1 2 0 1 2. Okay, pi m of 3 in the sense, see here, I'm going to take this expression. Pi m of 3. Okay, a is 1, b is 1. We can write complement because it is a max term. Max term will get, okay, we are going to write the complements. Okay, 1 came complement a bar. B is 1 means B bar. In between these two sum term, it's a sum term, A bar plus B bar. If you apply De Morgan's law, A bar plus B bar is equal to AB whole bar. AB whole bar. If you observe well here, and expression is which one ma? And expression is A dot B. If you apply not gate, what will you get ma? AB whole bar. AB whole bar is for which one ma? NAND gate. Please keep in mind. Okay, AND gate expression is A dot B. If you apply not, okay, what you are going to have? A dot B whole bar. Here also finally we got as a y is equal to A dot B whole bar. This is NAND gate. And these all are very, very important formulas. Listen carefully. Okay, appare in the sense NAND. Appare in the sense NAND. Okay, I'm going to write. Okay, I will explain one thing here, then I will explain this one now. 1 NAND 0, what we are going to get? Okay, based on truth table itself. 1 NAND 0 means 1.0 whole bar. 1.0 whole bar. 0 dot anything is 0, whole bar is 1. Understand or not? Based on that, I'm going to write here. Listen carefully. Okay, A NAND 0 is 1. Because why A NAND 0 is 1 in the sense, I can write A dot 0 whole bar. Okay, just now I said any one of the input is 0. Okay, for NAND gate output is 1. Yes, they are getting. Please keep in mind. Now A NAND 1 means A dot 1 whole bar. A dot 1 whole bar. Okay, A dot 1 is A bar. What we are going to get? A bar. Please keep in mind. This is very, very important. Okay, A NAND A bar. Both are complement each other, definitely. Both are complement each other. Is it correct or not? See here, A dot A bar and whole bar. Now we know that A dot A bar is 0. 0 bar is 1. That's why I'm writing 1. Okay, A and A. A NAND A means A dot A whole bar. A dot A, according to the idempotent law, I can write A and whole bar. A dot A, sorry, A NAND A is A bar. Please keep in mind these two functions. Okay, A dot of, sorry, A NAND of 1 is A bar. A NAND of A is A bar. This we can call it as a invert function or complement function or not function. Please keep in mind, not function. This is very, very important. This will be, okay, these 2 points will helpful furthermore. Please keep in mind. Okay, I will tell for NAND gate, one input is, for NAND gate, one input is, okay, A and 1 is there, A bar. Or both inputs are same, I can get as a bar. Please keep in mind. Now, enable and disable input. Here itself I can tell from these two. You can tell me from these two, I can tell enable and disable input. From these two, I can tell enable input and disable input. How we are going to find out enable input and disable inputs, ma? One input is fixed at A. Another input you can apply 0 or 1. If you apply 0, this A is not, okay, this A is, okay, not appeared at the output, means it is disabled. For NAND gate, 0 is disabled. For NAND gate, 0 is disabled. Okay, ఇప్పుడు చూడండి ఇక్కడ 1 అప్లై చేస్తాను NAND గేట్ కి ఏమొచ్చింది మా A బార్ వచ్చింది అంటే ఫిక్స్డ్ అయిన ఇన్పుట్ అవుట్పుట్ సైడ్ వచ్చింది బట్ కాంప్లిమెంట్ గా వచ్చింది A came here but కాంప్లిమెంట్ గా వచ్చింది దట్స్ వై enable input is 1, disable input is 0. Please keep in mind. Disable input is 0. Next, NOR gate. Not OR is NOR. Not OR is NOR. Okay. OR gate game cheppanu. What is the logic? I said any one of the input is 1, output is 1. Ikkada em avutadi? Okay, when one of the input is logic 1, then output is logic 0. Then we are going to get opposite. Here min terms and max terms. Min terms and max terms. Okay, min term basis I can write. Okay, I'm going to write the expression summation m of 0. Then ఇది min term లో A0 B0 ఉంది అంటే ఏమని రాయొచ్చు A bar B bar A bar B bar. Min term is a product term. A bar dot B bar, that is equal to what I can write, ma? According to De Morgan's law, A plus B whole bar. A plus B whole bar. According to the De Morgan's law, A plus B whole bar. Okay, understand? OR gate చెప్పండి ఏంటి మా? OR gate కి OR gate, what is the expression? A plus B. If you apply not, okay, not OR is NOR, right? Not OR is NOR. If you apply NOR, what will get? NOR gate. What is the expression you will get? A plus B whole bar. And symbol చూడండి మా, ఇది OR gate, same OR gate. Okay, నేను ఆల్రెడీ చెప్పాను బబుల్ ఏం చేస్తుందమ్మా, బబుల్ ఈజ్ గోయింగ్ టు గివ్ ద కాంప్లిమెంట్ అవుట్పుట్. అందుకే ఇక్కడ OR gate కి బబుల్ యాడ్ చేశాను. సేమ్ వే NAND gate చూడండి ఇక్కడ, ఓకే, సింబల్ ఇక్కడ డ్రా చేయలేదు, సారీ, ఐఎమ్ గోయింగ్ టు డ్రా సింబల్ హియర్, సింబల్. ఓకే, NAND gate అంటే నాట్ AND. This is a AND gate. For AND gate, we are going to keep bubble. Y is equal to A dot B whole bar. Okay, here OR gate also same. Understand? And here these formulas are important. Down arrow means what it means? Down arrow NOR అని గుర్తుపెట్టుకోండి. A NOR of 0. A NOR of 0 అంటే మనం ఎలా రాస్తాము? A NOR of 0 అని ఎలా రాస్తాము? ఇక్కడ A plus 0 whole bar expression లో. Is it correct or not? Just now I said the expression. What is that? A plus B whole bar. B plus ఏముంది మా 0 ఉంది. A plus 0 whole bar. A plus 0 is A, then it is a A bar. A plus 0 is A, then its having bar is A bar. Okay, here A NOR of 1. Okay, A NOR of 1, how we can write? A plus 1 whole bar. 1 plus anything is 1. 1 bar is 0. We'll get 0. Okay, A plus A bar whole bar. A plus A bar is 1. 1 bar is 0. Okay, A NOR of, okay, A means A plus A whole bar. A plus A is A bar. ఇప్పుడు బాగా అబ్జర్వ్ చేస్తే ఈ రెండు కాంబినేషన్ ఇన్వర్ట్ ఫంక్షన్, దీస్ టూ కాంబినేషన్ ఇన్వర్ట్ ఫంక్షన్. ఎనేబుల్ అండ్ డిసేబుల్ ఇన్పుట్ ఎలా రాస్తున్నామో, ఎనేబుల్ అండ్ డిసేబుల్ ఇన్పుట్ ఐఎమ్ గోయింగ్ టు రైట్ విత్ ది హెల్ప్ ఆఫ్ దీస్ టూ. చెప్పండి ఎనీవన్, వాట్ ఈస్ ద ఎనేబుల్ ఇన్పుట్ అండ్ డిసేబుల్ ఇన్పుట్? చెప్పండి, వాట్ ఈస్ దట్? టెల్ మీ ఫర్ నార్ గేట్. వాట్ ఈస్ ఎనేబుల్ ఇన్పుట్, వాట్ ఈస్ ద డిసేబుల్? హియర్ ఏ ఫిక్స్ చేశాను, 0 అప్లై చేశాను, అవుట్పుట్ ఏమొచ్చింది? ఏ బార్. అంటే ఈ ఫిక్స్ చేసిన అవుట్పుట్ ఇక్కడ వచ్చింది, ఎనేబుల్ అయింది, బట్ కాంప్లిమెంట్ ఫామ్. దట్స్ వై ఎనేబుల్ ఇన్పుట్ ఈస్ 0, డిసేబుల్ ఇన్పుట్ ఈస్ 1. ఇక్కడ చూడండి, ఏ ఫిక్స్ చేశాను, 1 అప్లై చేశాను, ఏమొచ్చింది? అవుట్పుట్ 0 వచ్చింది. అంటే ఏ రాలేదు నాకు అవుట్పుట్, అంటే ఏ అనేది డిసేబుల్ అయిపోయింది. ద ఫిక్స్డ్ ఇన్పుట్ ఈస్ డిసేబుల్ అట్ ద అవుట్పుట్ సైడ్. దట్స్ వై డిసేబుల్ ఇన్పుట్ ఈస్ 1. ఓకే, దిస్ ఈస్ అబౌట్ the basic gates and universal gates. Okay, next. Okay, already 10:35. I hope so 10:45 other class will start. Okay, listen na. Ippudu meeku I am going to show that okay, I created Google Classroom. I will share the link, everyone join. I already uploaded a few files here from the first unit. Okay, I will share the link. You have to join that Google Classroom.